Hello students, welcome to another session of integration by using trigonometric identities. So in the last session we discussed some of the examples from exercise 7.3 and here are remaining one. So here is question number 11 from exercise 7.3. Okay, so you're asked to integrate cos power 4 2x. Okay, now in the last class I did sin power 4x. Okay, so here it is cos power 4x, same method you have to follow. So let us call I is equals to cos power 4 2x dx. Okay, so I can write it as cos square 2x whole square dx. Okay, now as we all know, one of the identity I mentioned, cos square x is 1 plus cos 2x by 2. Okay, cos square x is this much. So now we have cos square 2x. So this becomes double. Okay, so it becomes 1 plus cos, double of this is 4x by 2 whole square dx. Remember that cos square x is 1 plus cos 2x by 2. If this is 2x, this becomes 4x. Okay, so 2 square is 4 in the denominator. In the numerator, you have to use this expansion a plus b whole square. A plus b whole square is a square plus b square plus 2ab. Okay, so what we will get? 1 square is 1 plus cos square 4x plus 2ab means 2 into 1 into cos, that is 2 cos 4x into dx. Okay, which is equals to 1 by 4 outside integration 1 plus, now again you got cos square 4x, so cos square again you write it as 1 plus cos double of this 8x by 2. Okay, as I mentioned earlier, cos square is, look here, cos square x means 1 plus cos 2x by 2. So similarly here it is 4x means you will get its double 8x plus 2 cos 4x as it is into dx. Okay, now you can write directly integration, otherwise you take LCM and then integrate. Both can be done. Okay, to avoid confusion I take 2 as LCM. Okay, multiplied by 2 plus 1 plus cos 8x plus 2 into 2 4 cos 4x dx. Okay, further this is 1 by 8, 4 into 2 8, integration of 2 plus 1 is 3 plus cos 8x plus 4 cos 4x dx. I suppose you understood. Now you can integrate. It's a 1 by 8, integration of 3 is a constant, integration of any constant is constant into x, so integration of 3 is 3 into x. Integration of cos 8x, it is sine 8x by 8 plus 4 into integration of cos 4x is sin 4x by 4 plus c. Okay, so this is question number 11th. Let's have question number 12. Okay, here is the question number 12. Integrate, you are asked to integrate sin square x by 1 plus cos x dx. Okay, so sin square x can be written as 1 minus cos square x divided by 1 plus cos x dx. Okay, now in the numerator you have a square minus b square. Remember this, a square minus b square means a plus b, a minus b. So a square minus b square is a plus b into a minus b. So 1 minus cos square can be written as 1 plus cos x into 1 minus cos x whole divided by 1 plus cos x into dx. Okay, now this 1 plus cos x, 1 plus cos x cancels. You will left with integration of 1 minus cos x dx. Okay, now you can write integration of 1 is x minus integration of cos x is sin x plus c. Okay, so 13th one is already done in the previous class. So let's have example number 14. Okay, integrate cos x minus sin x divided by 1 plus sin 2x dx. Okay, so you make use of identity. So numerator as it is, I will write 1 plus sin 2x. So 1 means I write cos square x plus sin square or sin square x plus cos square. As you all know, 1 means cos square x plus sin square x plus sin 2x means it is 2 sin x cos x into dx, which is equals to cos x minus sin x divided by, this is of the form a square plus b square plus 2ab. That means a plus b whole square. So I can write it as cos x plus sin x whole square dx. Even you can write sin x plus cos x. Okay, look at this. This is of the form a square plus b square plus 2ab, which is a plus b whole square. Now look, try to do it by substitution. Derivative of cos x is minus sin x, derivative of sin x is cos x. So go for substitution. Put cos x plus sin x is equals to t. As you all know, substitution method. Differentiate with respect to x. Okay, derivative of cos x is minus sin x, and derivative of sin x is cos x, equals to dt by dx. Okay, so you can write it as cos x minus sin x, I'll write positive note first, into dx equals to dt. Okay, now see here what I reduces to. This is your I. Cos x minus sin x dx is dt, so I can write dt whole divided by, this is your t, cos x plus sin x, so it is t and whole square. Okay, this turned into a very simple term. Now as we all know, integration of 1 by t square, that is 1 by x square, is minus 1 by x. So you can write this. Please note down this. Integration of 1 by x square dx is minus 1 by x. Okay. So in the same way, integration of 1 by t square is minus 1 by t, and your t is cos x plus sin x. So this is minus 1 by cos x plus sin x plus c. Okay, so this is your example number 14. Let's have 15th. Integrate tan cube 2x into secant 2x, sec 2x. Okay, so I write it as tan cube, I write as tan square into tan, I write. Okay, now see this, tan square means, look at this, I had given in the beginning tan square in terms of secant square, it is a secant square x minus 1. So this tan square I write it as secant square 2x minus 1 into, this is tan x as it is, into sec 2x dx. Okay, now we split it, this into this full term, secant square 2x into tan 2x into sec 2x minus this into this, tan 2x into sec 2x dt. Okay, okay, just this into this, this into this. Now write two separate integrals. One can directly write at this stage two separate integrals. Okay, by practice you will get such ideas. Secant square 2x into tan 2x into sec 2x dx, one term, minus integration of this tan 2x into sec 2x, this is 2x dx. Okay, now see here, there is no problem with this. This is exactly derivative of sec. Okay, so its integration can be written directly. Now at this stage, look here. Derivative of sec, if you put sec as t, so derivative of sec will be sec into tan. Okay, it is here. This is the derivative of sec. So I can put in the first integral. Put sec tx is equals to sec 2x is equal to t. And if you differentiate this, derivative of sec will be sec 2x into tan 2x. Further derivative of 2x is 2. Remember this. Equals to dt by dx. Okay, this is in first term you have to put. In first integral. Second integral as it is. And this gives you sec 2x into tan 2x into dx equals to dt by 2. Okay, bring this 2 down. This 2. Okay, now substitute here. Look here. This becomes t square and this is your dt by 2. Therefore, I is equals to integration of t square is secant square means t square. Next sec x tan x or tan x sec x is dt by 2. Minus, look at this. This is the derivative of sec. I will write as it is. Sec 2x into tan 2x dx. Okay. Integration of t square is t cube by 3 into this 1 by 2 as it is, by 2 constant. This is the derivative of tan, sec. So you can write it as its integration is sec 2x by 2. Okay. See here I have mentioned in the beginning integration of sec ax into tan ax is sec ax by a. Okay, so similarly here a means 2, this you have to write. And finally you substitute t you have taken as sec 2x. And this is sec 2x and this is being cube you have to write sec 2x by 2 plus c. Okay, either write cube here or sec cube, no problem. This is your question number 15. Let's have another example, 16th one. Okay, you are asked to integrate tan power 4x with respect to x. Okay, so tan power 4 you can write tan square into tan square x dx. Okay, so now this tan square x you have to write it as secant square x minus 1 and this tan square x as it is. Okay, now get multiply this into this. So sec square x into tan square x dx, I write first integral this into this minus second integral I write 1 into tan square is tan square, so separate integration I can write. Okay, so we have written two separate integrals by multiplying. Now again look at this. Derivative of tan is secant square. So you can put or better I'll make one small arrangement simultaneously. You can write. Okay, I can write like this. This is tan square x into secant square x minus this tan square can be written as again secant square minus 1 dx. Okay. Now this sec square is the derivative of tan. So put tan x is equals to t in first term. And if you differentiate this, you will get secant square. And which gives you secant square x dx is dt. Okay, so make this substitution in first term, and this is no issue, you can write directly. So I becomes integration of tan square, tan means t, so it is t square into this secant square x dx is dt. Okay, this secant square x dx is dt minus integration of secant square x minus 1 into dx. So right, integration of t square is t cube by 3 minus integration of sec square is tan x because it's a derivative of tan x minus integration of 1 is x plus constant c. So now replace t andre eno, you have taken t as tan x. So this is tan x by tan cube x by 3, cube irodrinda you can write cube minus tan x, and if you want you can minus into minus plus x plus c. Okay, so you must be good at the trigonometric identities. Let's have question number 17th. Integrate, it is sine cube x plus cos cube x divided by sine square x into cos square x dx. Okay, so this gives you, separate the terms first. I can write it as sine cube x by, one can write directly sine square x into cos square x plus cos cube x by same thing sine square x into cos square x. Okay, into dx. Okay, in this sine square cancels, one sine remains. Here cos square cancel, one cos remains in the numerator. So sine x by cos square x plus cos x by sine square x. Now sine x by cos x into 1 by cos x you will get. Okay, for your understanding I will write here, one can write directly. I will write it this form. Here also cos x by sin x into 1 by sin x I hope you understood. Now see here, sin x by cos x means tan x. 1 by cos is secant x. Cos x by sin x is cot x. 1 by sin is cosec x. Okay. Now they are the derivatives. Okay. So this is the derivative of sec and this is the derivative of minus cosec. So you can write its integration is sec x, integration of cosec into cot I have written already, so it is minus cosec x plus c. Okay. Let's have question number 18th. One, I equals to cos 2x plus 2 sin cube x, sin square x divided by cos square x. Okay. Now see here, as we all know, this cos 2x I will write as it is 2 sin square x. Okay, so this is a straightforward 2 sin square x is 1 minus cos 2x, because we know that sin square x is 1 minus cos 2x by 2. So this 2 is here. So you can write it as 2 sin square x is 1 minus cos 2x whole divided by this cos square x dx. Okay. Now this cos 2x cancels. You got simplest one, that is 1 by cos square. This is your secant square x. Okay. So secant square, integration of sec square is, it is tan x plus c. Okay. Simple one. Let's have question number 19. Of exercise 7.3. I is equals to 1 by sin x into cos cube x dx. Okay. Now as earlier, 1 I write, 1 can be replaced as sin square x plus cos square. Okay, in the denominator we have product, so it can be very easily separated to the numerators. So that is the reason I have written. Okay, 1 is replaced by sin square x plus cos square, remember. Okay, so because 1 is nothing but sin square x plus cos square x. Okay. Now I write it as sin square x by sin x into cos cube x plus cos square x by sin x into cos cube x. Okay. Which is equals to, now one sine term get cancels. Here cos square cancels. So here one sine remains in the numerator and in the denominator you left with cos cube x. Here 1 by you left with sin x into cos x dx. Okay. So further, I will write it as sin x by cos x one term into 1 by cos square x. And this, look at this. We know this 2 sin x cos x is sin 2x. Okay, 2 sin x cos x is sin 2x. So we have sin x cos x means sin x into cos x means it is a sin 2x by 2. Okay. So I write it as sin 2x by 2. Okay, you can do it by any other method also. Okay. So there are various trigonometric identities, so you can make use of suitable identities. So sin x by cos x means it is a tan x into 1 by cos square is secant square x plus I can write it as 2 into 1 by sin means cosec. Yes. Now very easily you can write two integrals. It is tan x into secant square x dx, 2 into integration of cosec 2x dx. Okay. So integrate now. Tan x derivative is secant square. So put tan x is equals to t. Its derivative is secant square equals to dt by dx. So secant square x dx is dt. So therefore I becomes, this is your t and this is your dt plus 2 into integration of this. You can write directly integration of cosec 2x, integration of cosec ax. Remember this, integration of cosec ax is log of cosec ax minus cot ax whole divided by a. So I write it as it's a log of cosec 2x minus cot 2x whole divided by 2 plus c. So integration of t is t square by 2 plus this 2 cancels and you write as it is log of cosec 2x minus cot 2x plus c, and finally replace your t. What t is? You have taken t as tan x. So this is tan x whole square by 2 and this as it is. Okay. So this is exercise, that's a problem number 19th. Let's have 20th one. integrate, it is cos 2x divided by cos x plus sin x whole square. Okay, into dx. Cos 2x, as we all know, it is cos square x minus sin square x. Okay, please note down this one identity. Cos 2x is cos square x minus sin square x divided by, this is cos x plus sin x whole square. Okay. Now here in the numerator, it is of the form a square minus b square. So you have to write a plus b, a minus b. So cos x plus sin x into cos x minus sin x divided by cos x plus sin x whole square into dx. Okay. Now one term get cancels. This cos x plus sin x cancels with one factor. So you are left with cos x minus sin x divided by cos x plus sin x. Okay. Now very simple. Derivative of this is here. Derivative of cos is minus sin, derivative of sin is cos. So you can directly write, if numerator is the derivative of denominator, it is log of denominator. Okay. Because I had given you the property in the previous classes. So if numerator is the, otherwise you can substitute. If you substitute this on differentiation, you will get this. So you will get 1 by t, and integration of 1 by t is log t. Log t is this. Or you can use directly, I have written directly integration of f dash by f. If numerator is the derivative of denominator, its integration is log of f of x. So please do remember this. Okay. Now 21st one. Integrate sine inverse of cos x with respect to x. Okay. So very simple. Sine inverse of, I write this cos in terms of sine. I write sine as cos as sine pi by 2 minus x. Okay, because you know this sine pi by 2 minus theta is cos theta. Okay. Now in the inverse trigonometric functions you have studied, sine inverse of sine is just remain with this pi by 2 minus x dx. Okay, sine inverse into sine, you can remove those. Now pi by 2 is a constant, so integration of any constant is constant into x. So you can write pi by 2 minus x. Integration of x is x square by 2 plus c. Okay, remember this. Integration of k with respect to x is kx. So that is why integration of pi by 2 is pi by 2 x. Okay. Now we'll have question number 22nd. Little bit tricky. Okay, I is equals to integration of 1 by cos of x minus a into cos of x minus b into dx. Okay, so in order to evaluate this, just I multiply and divide by I'll take some extra term, sine of a minus b. I will multiply and divide by sine of a minus b. Okay, it's a constant. Okay, sine of a minus b I have written here. This is sine of a minus b outside, and inside the integral sine of a minus b divided by this as it is, cos of x minus a into cos of x minus b. Okay, there is a small adjustment you have to make so as to get the result. Okay, 1 by sine a minus b as it is. Further, okay, with this you can't do anything. So first again I'll write it as this a minus b can be written in this form, x minus b minus x minus a. Okay, again I have added and subtracted x. That is the thing here. What I have done here? Add and subtract x. Yes, add and subtract x within this sign, and that is written in this form. If you open the bracket, you will get minus of minus plus a will get. Okay, so this minus b will get. So just small arrangement I have made, divided by as it is, cos of x minus a into cos of x minus b into dx. Okay, this is 1 by sine a minus b as it is. Now look, this is the form sine a minus b. Sine a minus b is, please note this, sine of a minus b is sine a cos b minus cos a sine b. Okay, so write that sine of a, sine of a means x minus b into cos of x minus a minus cos of x minus b into sine of x minus a divided by as it is, this as it is, cos of x minus a into cos of x minus b integration dx. Okay, separate the terms and whatever the remaining you write. It's a 1 by sine of a minus b. Now if we divide this term by this term, full term, in this what get cancels? Cos cancels, cos of x minus a by cos x minus a. You will be left with sine of x minus b by cos of x minus b. Here, if you divide this by this, what get cancelled? This get cancels, cos x minus b. So you left with sine of x minus a by cos of x minus a. Okay, it's a 1 by sine x a minus b into integration of sine by cos means tan x minus b minus tan x minus a dx. Okay, now you got at the end which is equals to 1 by sine a minus b. Okay, write the integration of tan. Integration of tan is, it is log of sec x minus b minus log of sec of x minus a plus c. Okay, so if you want further, you can write 1 by sine of a minus b, okay, log m minus log n is log m by n, so you can write it is sec of x minus a by, sorry, x minus b by sec of x minus a plus c. Okay, so these are the examples from 7.3. So practice these and we will meet in the next session with some standard integrals. So take care and keep watching.